Hello. Okay, this video presentation, or this video tutorial, has been created to help you build maximum and minimum lines of fit onto your graph using error bars, and after constructing these maximum and minimum lines of fit, we can then use the gradients from those lines to calculate something called graphical percentage error. Okay, at the moment on this Excel file you can see several things. The first thing I want to look at is this table of data. Now in this table of data I've got my raw data, mass and force, and I've gone and included uncertainties. I haven't got repetitions because I'm just using this as an example. So once I've got my mass and force values, we should know by now that if we divide force by mass we can calculate gravity, which is what I've gone and done in this column. And by changing my mass and force values into possible percentage errors rather than possible errors, I can then use these percentages to calculate gravity by adding them together, or by calculating the percentage error for gravity by adding them together, and then convert them into a possible error using this percentage and the gravity value. I'm going to upload this file to Haiku, so then you can actually work through the cells and you can actually see the equations I've used, but these are things we've gone and spoken in the past, and I'm just presenting them to you so that you can see them again. The one thing we haven't done though is to actually show how we should actually take averages for our final values. Now at the moment we've got gravity, newtons per kilogram, which is our final value, and we've got about 9 values here. Notice that the first line is blacked out because this is 0, and obviously anything divided by 0 doesn't actually count, but it actually makes a point on the graph which is useful. So to calculate averages, which I've done down here, I'm basically using an equation called average, and all I do is I basically go, I'll show you how to do this, press equals, we say average, and as soon as we say average, hopefully equals average, you should see that it gives you the option of using an average equation. I select the average equation, I then select all the cells that I want to average, and Excel will then give me an average. Now obviously everything in here is to 2 significant figures, so basically I'm going to make this also into 2 significant figures, which gives me an average of 10. I've also gone and done the same for the gravity error. Now obviously the gravity error is quite large, and the reason why the gravity error is large is because I've got a tutorial and I've made up these values to start off with. But this final gravity value plus or minus error gives you the final answer for your process data. Now what we need to do is we need to actually make this look visual, or we need to make our errors look visual graph-wise. So you can already see in this graph that I've included horizontal and vertical error bars, I've included a trend line, and I've also included a trend line equation, everything that you should already be able to do. I've also going to put some nice little labels and a title. Right, to calculate graphical percentage error, we need to include 2 extra lines onto the graph. These are going to be the minimum lines of fit and the maximum lines of fit. The minimum lines of fit are going to be the shallow lines that are running from my lower data point outer error bar to my upper data point outer error bar. So I'm going to run a line from here, with my arrow is, down to here. And that's going to be my minimum line of fit. It's where my line will most minimum achieve through those data points. The maximum line of fit is going to be from the lower and the upper data point, but they're going to be the inner error bars from here and to here. But we need to put these onto Excel. To do this, we have to make 2 extra cells of data. One called minimum line of fit, one called maximum line of fit. Now to do the minimum line of fit, we're interested in the error bars that are the most erroneous. So you can see that the vertical error bars aren't that erroneous and are not affecting my data that much, but the horizontal ones are. So I'm, as pointed out before, I'm interested in using those inner and outer points. To do this, I'm going to use my first data points and my last data points. You can see in this table of data that the force values stay the same because I don't think that they're really affecting the graph that much. But my mass data points have changed. To do this, I've gone and taken 0.00 and I've gone and subtracted 0.1 from it to give me an answer of minus 0.1. For the upper extreme point, I know that my mass value is 1, but then I want to add 0.1 to it. So I end up with minus 0.1 and 1.1, which will be this error bar and this error bar. I then need to put that data onto the graph. To do this, I'm going to select the axis. Any axis will do. I'm going to right click, I'm going to select data, and what I'm going to do is I'm going to add an extra column of data. Now you can see that we've already got the line of best fit data in there, and I changed the name line of best fit just by typing line of best fit in here. If I add a data source, I'm now going to call this my minimum line of best fit. Now, I then need to choose my X and Y values. Notice that the minimum line of best fit goes in here. So my X values are going to be my mass values. So I'm going to collect my mass values, click on those, expand the column, and my Y values are now going to be my force values. I can then go and select the force values and expand the column. Now, hopefully, if I click OK, you should now see that there is now a line running from this point to this point. This is now my minimum line of fit. I can then go and do what I've normally do with all trend lines. I can add a trend line to that. I can change the line color. So I'm going to change the line color to red. I'm going to go into options and I'm going to display an equation on the chart and I'm going to click OK. And now what you should be able to see is I now have a gradient for my minimum line of fit, which is a gradient less than my actual best fit trend line. I'm also going to go to my legend and I'm going to delete this one so that I can just leave line of best fit, maximum line of best fit. Right, similarly I'm going to do exactly the same for my maximum line of best fit. I'm going to go and select the data, I'm going to right click, I'm going to select data, I'm going to add, I'm going to call this maximum or max line of best fit, and then I'm going to I'm going to select my X values, which are going to be my mass values, and now you can see that my mass values have changed. I've gone from 0.00 to adding 0.1, which gives me 0.1, and I've taken 1 and taken off 0.1 to give me 0.99. So if I select these two data value points and expand, and then I go and choose my Y value data points and expand, select those and then expand, then hopefully if I click OK, I should now not oh sorry, that's why. Okay, my green line is now starting from here, but I have this data point incorrect, so I now need to go back and change it to 0.9, and then hopefully if I press return, there you go, it's gone and moved. So it's going to move this data point to where it should be, because this is 0.9, not 0.99. My mistake. Again, I can select that set of data, I can add a trend line, I can change the line color, so I'm just going to change it to some sickly green color. I'm going to go to options, I'm going to go to display equation on chart, and I'm going to click OK. And now you can see that I've gone and got an extreme value of an extreme gradient. So I now have a gradient of 13 newtons per kilogram for that. Now what I'm going to do is I'm just going to try and just arrange these just so that I have, oops, sorry a minute, format the trend line, okay, right, now what I'm going to do is I'm just basically going to expand this data box. So I'm going to expand this, I'm going to get rid of this maximum line, so I've just got these, and now what I'm going to do is I'm just going to manually put in my trend lines underneath or my trend equations underneath, so it makes it just look a bit prettier. Right, so now I've gone and included maximum and minimum lines of fit. So now what I'm looking at is I'm looking at extreme values. I know that my maximum line, I know that my line of best fit is 10.156 newtons per kilogram. I know that my minimum line of fit is 8.667 newtons per kilogram, and I know that my maximum line of fit is 13 newtons per kilogram. I'm then looking for which of my minimum or my maximum is the most extreme, and obviously 13 is a bigger difference to 10 than 8.66 is to 10.156. So to do my graphical error, I've already got the equation in here for you to use. I would then say that my graphical error is gonna equal to my best gradient, which is 10.156, minus my worst gradient, which is 13, divided by my best gradient, which is 10.156, and then I can multiply this by 100%. Now obviously at the moment I haven't got my calculator with me, but this would then be my graphical percentage error, and I should really call this graphical percentage error. Okay, and I should call this graphical percentage error. So I will then have a percentage of whatever value would be to go along with my 10.156 newtons per kilogram. So once I then have my 10.156 newtons per kilogram plus or minus this percentage, I can then convert that back into a possible error, like we do in the process table. One last thing, and I'm just going to show you one other thing that I did with my IB students. If you just bear with me for a second. Oh, wrong. Kinematics. No. Oh damn, where are you? Sorry, it's under measurements, isn't it? Okay, this is the source of data I'm looking at. Right, you can already see what I've gone and done here. So, this is my source of data, which looks very similar to what we've gone and done before. If I go to sheet 2, I've got a graphical, I've got my lines of best fits, maximum line of fit, minimum line of fit. Now what I've gone and done is I've decided that in this graph, the X and Y value data points are very similar and very erroneous. So instead of using the upper limit and lower limit of one data point, I've used the upper limit and upper limit of both data points to put this point here. Same thing goes with the green one. So if I go back to my table of data, my maximum and minimum lines of best fit, for this I've gone and subtracted 0.02, but for this I've also gone and subtracted 0.4 to change this source of data. So I've still got maximum minimum lines of best fit, it's just this using upper limits from both and lower limits from both. I've then got this little box here where I've got my best gradient, I've got my worst gradient, I've gone and calculated my percentage error, which gives me 6%. I've then said that my best gradient is 10.2 plus or minus 6%, and then I've changed this 6% of this value to give me an actual error. So now that you know how to do this, you should be able to apply maximum and minimum lines of fit to your graphs for the up-and-coming gravity error lab that's to do with sensitivity of force meters. Okay, thanks for listening. Bye-bye.